In this session, we're going to show how to make plots for publications and presentations. As usual, I've set up a test directory, and I have my alias. So we start Specpr with this command. And what we're going to do is first plot some data, and we're going to plot some data on the screen from the spectral library 06. And what I'm going to do is this list of reflectance data is from 2007, so it lacks the pointers to the wavelengths and resolution. So I'm going to create a new one just in the current directory, and we'll call it the same thing. Oops, before we do that, we have to grep for just reflectance data, then put it to a file name. Then we can search it. So I thought, as an example, we'll plot this spectrum and this spectrum. So first, so the spectral library 06 is assigned to W, so W1388, and we see that the wavelengths are W10, so I can type capital W10, or I can just type ampersand, and it gets the wavelengths from the record pointer. So that spectrum looks good. Then the other spectrum, 1702. Oh, excuse me. Let's do, well, we can do that one. Let's do both Beckman spectra. So the B here is Beckman. So let's use 1411. And this is a larger grain size, so it shows more contrast. And compare that with 1702. Okay, so if we want to plot both of them, question mark shows history, so we can look at O for overlay, and overlay the second one too. So those are the two spectra. Whoops, that's the wrong two, isn't it? We wanted 1411 O and the 1702 O. So let's say we wanted to make a plot of these. Now what's interesting here is it looks like there's a grain size difference, but it looks like some absorption bands are at the same location and some are at different locations, showing different composition to the alunite. I've recorded some of that, and I like to do this a lot, overlays.txt. So if we just make OV1, so overlay 1 is 1411, and then the advantage of doing that, then we can just do the 1702. Where's my overlay? There we go. Now we can set up wavelengths markers to see any shifts. So we do a capital G, and we can read off band positions here. So 1.764 and so on. But it's hard to tell if these line up. So we can do wavelength markers, turn off the graphics cursor read, and we can just read these in. come that didn't... oh, it's confused that I shouldn't put the blue on there. There we go. Only do those. I should change the program to ignore those. Really what you can do is you can specify up to 5 wavelengths all the same color, and so it's confused by blue thinking it should be another number. One solution to that is to make that a comment. Then you can cut and paste those lines. Okay, but now we can see that the wavelengths here don't line up. For this feature, they do for this one and these. So that's curiosity. It looks like these don't line up either. So let's just make a plot of these two that is better than the single pixel wide low resolution fonts. So we can exit there, have that up. So we can see P for plots. So we have an option of, this is a very old HP pen plotter. There's also make postscript plots, so you can import the postscript into like Adobe Illustrator if you want to make really very high quality plots. I found Tgif is simpler. It's easier to move things around, and it's a simple program that runs on Linux, is free, and so we'll do Tgif plots. We can let the wavelength range float, or we can, based on the input data for these two spectra, or we can fix it. So if we just press return, it's auto-scaled. But I usually prefer to set the range myself, and 0.3 to 2.5. This data is in reflectance, so we can just type 6, or if you want to do your own custom label, you can do that. The vertical range of the plot, 0 to 1. Now I'm going to exit here because I forgot to do one important thing. Hard exit. We're now at the beginning. It's good to record your commands, and I'll show you why. So this is plot to alunite. And this is, I call my versions A, B, C, so this is version A. Now all the commands we do are recorded, so if we want to change something on the plot, we can just edit this file and then re-execute it. So again, T for Tgif, 0.3 to 2.5, reflectance, 0 to 1, and we can leave the default size of the plot, or we can shrink it. Sometimes you want the aspect ratio to change for a particular publication. We're going to let it be the default. If you have spurious points, you can delete those. Like that's probably not real right there, but we're going to ignore that for now. But you can do individual, you can plot, or you can delete from all the spectra or data that's going into the plot via that, or when we select which spectra, we can delete like only this channel from this black spectrum. Okay, so we're going to do 1411, and here's where you do need to specify the wavelength pointer. So W6, and then we have all these options. I generally, for a line plot, want to connect the points, and there's a difference between connect points and connect point always. So a lot of spectrometers have overlap, like at 1 micron. It might be a spectrometer that goes to 1, and then the next segment of the spectrometer might start at 0.95, and so there's a retrace, and if you do a capital C, you'll see that retrace back to a shorter wavelength. So I generally use the lowercase c. Line type 1 is common, and then you can add points with a point size. For a line plot, point size 0. There's also symbol type, and the Specpr manual covers what all the different line types and symbol types are. You can do text on the graph. This is before we had graphical editors, so this isn't needed. It's easier to do it in like Illustrator or Tgif. If you have points that hit the limits, and you're doing symbols, you could have a whole bunch of symbols like down here or up at the top of your plot, and sometimes those are annoying, so you can type an N for no plotting of points. So there's a lot of options here. You can explore those, but this is pretty common. I do commonly do the N. Then there are other options that we're not going to use on this plot, but if you want to offset, you can type O, and like offset 0.1 reflectance unit or minus 0.1, or you can do multiply 0.5, or say your plot, especially beyond 3 microns, things get dark. You might want to extend part of that region and magnify it, so like you could magnify it by 5. We're not going to do any of that here. I also, so I know what I'm plotting, so this is 1411. I usually copy something like that. Let's move that up a little bit. Then our other spectrum was W1702, and again, its wavelength is 6, W6, and then the same kind of stuff. And now B to begin the plot. So the plot parameters have been generated. Now I'm in the same directory in this window here, and what Specpr does is create a plot. There's some dot files, so the .tgifplot.obj is the Tgif. Otherwise, it'll be a postscript .ps. It'll be .psplot.ps. So we copy this to this is so I can usually find my stuff. I typically want to say that it's a plot, have Tgif in the name, so I know it's one of the publication plots as opposed to a screen dump, and then something about the plot itself. I'd usually make this a little bit longer title, but this is good example. Now if we do Tgif, so this is the basic plot. It's quite basic in some ways. There's two things up here that says when you generated the plot, and there's another field up here that's blank that can be the name of the organization when Specpr is compiled, but we haven't set that, so we just delete those two things. I do a capital A to select everything, and then one thing, the font here is a Courier font, and I prefer a Helvetica font. The micron symbol is a custom, so Control unselect the micron symbol. Then I did a middle click and I can select Helvetica. Notice things changed the position a little bit, so I tend to have to move them over 1 or 2 spaces. Same with these. Then you can change the colors. This is the color set. This is a default color set that I've set up. Usually you have just a few colors, but if you bring in an image or like a color panel, it'll set the colors for you based on what you import. So let's make this one red and this one blue, just as an example. Then down here we have, if you want to build keys, let's see, we don't need the time, so we'll delete those. And we don't need the parameters. I'm pushing the delete key. This tells us what the spectra are, so I usually bring one of these up and change the name equals, and we don't need the R. You'll notice on all my plots I have these values there. That way, for any publication that I've done, just like an image, like a spacecraft image has an ID name, then your spectra have IDs, and if somebody wants the spectrum or you want the spectrum in the future, you know exactly where to go to get it. I usually make this a 14 point. The font sizes are generally while these font sizes here are what's available, they don't exactly correspond to actual point sizes in points on a screen. It depends on the screen and then your publication. So these points are large enough that I've never had any editor complain about size or anything, not even of these small things, since it's incidental to the details on the plot. So we don't need that now. Let's move this over. If you want to build a key, you can, I'm just using the arrow keys to move these around. If we go to text mode, you can get rid of that part that's not needed. This part that's not needed. And then this is the pointer mode again. I can move this up here. Make this one was the blue spectrum. Make that blue. Make that red. And because the red curve is on top, I would tend to change this. So there's a basic plot. It's ready to be exported. I usually select all. First, save the plot. Then middle button gives you options here. We want to save and export in color right here. And then we can select what format to save in. So embedded postscript, a GIF. I usually make a GIF, and that's usually what I submit to journals and what I import into PowerPoint. And you can see this ran a script and created a GIF file. If we now have our obj file and a Tgif GIF file. So this is what our put that down so we just see the plot itself. So we don't have anything extraneous sitting off that um, that makes the plot unusual size or something. So everything looks good here. We could submit that to a journal. So it only took a couple of minutes to do that. So we're done here. Go back to, oh, that's something else I'm going to show. Tgif, okay. There are other options for output. You can even do a PDF output, PNG, JPEG output. So you have lots of options. So we're done here. Just be sure we save that once we set the color range, and we're done. Now, let's say there was something that we didn't like about that plot. I wouldn't have done all the editing, but you can just edit this command file, and then we can go in again all of these times when you have a script, delete that last line. And let's say we wanted to change this to, no, excuse me, over here. So then we could regenerate the plot quickly without having to type it in. That was a very simple plot, but plots can get a lot more complex, and I was going to show these as examples. I'm going to move this over here. We're done with Specpr, so I'm going to exit Specpr. I'm not going to save this either. We're going to go into this directory, and you see here I just selected some plots for that I've created, looks like from 2016, 20, and 21. So let's look at, well, this plot is this one here. Let's look at the commands that generated that plot. So the black line is CRISM data, and the other three are lab data. And you can see that for the CRISM data, I deleted one channel. There was a spurious point. And all of these, for example, here, I deleted everything short of here because we're trying to compare the spectral features out here. So this just added confusion to show the spectrum all the way. So I deleted 1 through 1850 channels that deleted everything short of this. I did an offset. The offset was 0.02 and 0.04. So for the between the San Carlos olivine and the dolomite, we have different offsets here. So everything, and then you can do these offsets in Tgif. Let me bring up the Tgif again. We can do that. We're done with this, so we can bring this Tgif up again. So you can do offsets just by placing the arrow up and down. You really don't want to move with the cursor because you might grab the wrong thing like I just did there. Control Z will undo that. But if you grab the line and not a point, you can shift the wavelengths too. So that's not a good thing to do. So just using the cursor to move up and down is a safer way to not do any wavelength shifts. So explore Tgif. You can do a lot of very interesting things with it. I'm going to exit without okay, other examples of plots. Specpr is more than just wavelengths, so it's any XY plot. So here was CO2 frost as a function of grain size was generated with the rad-tran radiative transfer model. Then the band depths via a script was extracted, and the band depth versus grain diameter was made into a set of XY data. Specpr can plot this. You can do math operations on it just like a spectrum, but it just shows another example. Let's look at the let's see, that's this one here. So very simple. We had to select Y and set in our custom custom you know, label down here and here. So then we didn't have to offset anything, so it's just select them all and plot them. So very simple to do a plot like this. If you want to turn one off or something, you can just come down here and comment it out and regenerate the plot, or turn it back on, or maybe you want to add something else, just add it to this file and re-execute. In Specpr, you would just say less than and then the plot name, and it would execute that file again. And in fact, we could do that. We have this right here. So we've just re-executed and rebuilt the Tgif file. Then you'd need to edit it and change colors as you want. Then another example, you can do wave number. If you have your wavelengths or your X values in wave number, you can have them in both wave number and wavelength, so you can point to one or the other as you desire. So you have complete flexibility there. And here's another example with deleting points. It's the thermal. It's this one here. This is actually a very simple plot. I didn't need to do anything special in offsetting because these are modeled spectra. But we did delete some channels that were spurious. In this case, channel 324. And then here's another example where using a small c. So the small c will connect points unless there's a gap caused by a deleted point. So the 324 is a point that's over in here. If I used a capital C or didn't delete that 324 value, there would be a line here, and it just looks artificial. So that's a choice you can make. So and with that, and learning Tgif, or if you're comfortable with Illustrator, you can import these into Illustrator and work with them. You can do all kinds of different plots, and those plots easily drop into a PowerPoint presentation or LibreOffice presentation, and also into publications.